Okay, year 8. Sorry I can't be there today, but I've got a course I need to be on, and they only do it during inconvenient time. Sorry, there we are. What you're doing today in this lesson is area of trapeziums and parallelograms, not parallelogram. There's many of them. So in this, we start with a rectangle. So consider that. We think about, all right, we've got, the base and the height. There we go. So the area is just the base times the height, b times h. Hopefully you remember as well how you get the area of a triangle. So area of a triangle is the base multiplied by the height divided by 2. Why is that? When you think about a triangle, actually any triangle, its area is just a half of a rectangle with the same dimensions. We just cut it in half. So there we go. Now think about what is a trapezium, and I've spelt it wrongly there, which is absolutely shameful. Let me just get rid of that object eraser. It should be a U. I blame the iPad for reading my bad writing. Okay, so trapezium. You probably are familiar with them already in some way. It is a quadrilateral. That's not a quadrilatered, that's a quadrilateral. Let me just rewrite that as well. So quadrilateral, which means it is a four-sided shape, and it has got one pair of parallel sides. That's what makes something a trapezium. So for example, on our example here, there's Alice, and you see that I put these arrows onto it, and that shows me that we mean those sides are parallel. Okay, and we think about Bob here. Well, where are the parallel sides? Right here. And in each case, there's only one pair of parallel sides, and that's what these arrows show. We can see just by the sketch that these are not parallel, the ones on the edges. So the ones on the left and the right, I should say. So there we go, trapezium. It's quadrilateral with one pair of parallel sides, four-sided shape. So think about how we get the area. So what we can do is we can sort of imagine putting a line through the middle. So let's do that. I'll get a light pen. There's a line right through the middle there. Hopefully that's pretty much bang on through the middle. Now what I could then do is I could actually cut off this section. Right, so imagine cutting off this section and also cutting off this section. What I could then do is, let me see if, let's not do it over that. So this section I've just colored in, I'll just call this X, this section Y. It will fit exactly up here. So then what I would have is I would have a rectangle, and the area of that's much easier to get. But well, how do we get this distance here? How do we get this distance here? Well, we can't, not from this, because there's no actual measurements on this. And so what we're going to do is we're going to figure out, well, how do we get this distance at the top? Because that's the crucial one that we actually need. So what you need to notice, so let me just get rid of all those like little annotations. I'll put this up afterwards, by the way, so all these notes will be on Classroom afterwards. Oops, I didn't want to erase that. That middle line is really important, okay? So I'm going to call that X. So what you might notice, I'll call this top one B, A, call this bottom one B. And X is right in the middle of A and B. So for example, let's say A was 12 and B was 16. What is right in the middle between 12 and 16? So let's get this. 13, 14, 15, 16. It's 14. Okay, see that? But that's clunky, that's annoying. How do we actually figure out what that is? Well, X is just the mean average. So all we do is A plus B, and we divide it by 2. And that will give us the length of this middle line. All right, fine. But how do we actually get the area? Well, remember that we also have the height. We might be given the height in this case. And so this is imagining that the parallelogram was a square or a rectangle. I should say rectangle, squares are rectangles. And the height. So to get the area of any parallelogram, we just take A plus B, that's the top part plus the bottom part, divide by 2, and we multiply it by the height. And that is how we get the area of any parallelogram. So if you remember only one thing, I keep saying parallelogram, I mean trapezium. These are trapeziums. If I said parallelogram anytime apart from the very beginning, I'm sorry, please excuse me, I meant trapeziums. That's what we're talking about here. Anyway, if you remember only one thing, area of a trapezium is A plus B divided by 2 times H. That is the top part plus the bottom part multiplied, divided by 2 and multiplied by the height. So we'll do a worked example in this case. Now these here are also trapeziums. Just want to emphasize that because it's easy to forget because they have only one pair of parallel sides and they are both quadrilaterals. Let's say this is, I don't know, we'll say this is 15. We'll say this is 12. We'll say that this is, let's just say it's 9. And we'll say that this is 7. Now, why have I bothered putting the 9 down there? Well, because a lot of the time you'll be given something like this in the question, which is not actually useful to you. The idea is to make sure that you're paying careful attention to detail and that you use the numbers given to you correctly. So we've got the 12 and 15, and what we can maybe do is, whoops, I don't want the eraser. What we can maybe do is imagine that line across the middle. So what we'll do is we do 12 plus 15, and then that, taking the average of those, will give us that line across the middle, and then we just times it by 7. So when you see a trapezium and you ask for area, you're going to think, okay, A plus B divided by 2 times H. Anyway, let's sort this out. Our next step, so 12 plus 15 is going to give me 27 divided by 2 multiplied by 7. I'm going to do my 27 divided by 2. I'm going to leave that up to you guys. You can do your bust out method. Remember, I'll emphasize to you, you don't get any prizes for doing these things in your head. Okay, not even a single clap. 27 divided by 2 is 13.5. And then we multiply it by 7. And that's going to give me, not going to do this in my head. So 13.5 times, go away. 13.5 times by 7. Times by 7.0, so we'll do a multiplication method. 7 times 0.5, that gives me 3.5. 7 times 3 gives me 21. And 7 times 1 gives me 7, plus 2 gives me 9. So we get us 94.5. That was no quicker than if I'd done it in my head, I promise you. Oh yeah, and we should include units. Let's just say these all in centimetres. So our unit, remember when we're talking about area, is square centimetres. There we go. So that's your worked example on how you get the area of a trapezium. Now, moving on to our next one. What is a parallelogram? Well, hopefully you remember a parallelogram belongs to the same family of shapes as a rectangle, as a trapezium. They are called the quadrilaterals, four-sided shapes. You may at this moment think of some other quadrilaterals, for example, give you a bit of thinking time. There is the rhombus, which is something like that, sort of diamond shaped. There is the kite, similar to a rhombus, but you've got one pair of sides is equal, another pair of sides is equal. But anyway, that's what we're dealing with right now. What we're dealing with is our parallelogram. So what's a parallelogram? Well, it's a quadrilateral with, let me just get the right pen color, with two pairs of parallel sides. There's a dead giveaway. Let me just do my A's correctly. There's a dead giveaway in the name parallelogram. So you've got this side here is parallel with this side here, and the left and the right are parallel with each other. There you go, parallelogram. Now, getting the area of it. Well, let's use our example up here, because what we can also do with our parallelogram is, I'm going to use this pen and I'm going to draw something. I'm just going to draw over this. You might already see what it is I'm actually doing here. If I draw over this, and hopefully this works on this thing, won't let me move that small shape. This triangle I've just drawn will fit, if I was to cut that off, it will fit exactly in here. And again, it's going to give me a rectangle. So actually, area of parallelogram is really simple. Let's just say our base is 15 and our height is 4. Just base times height. It is just base times height. So the area of this thing is 15 times 4, which is equal to 60. 60 square centimeters, 60 square meters, whatever the units you're given. Worked example on this one. So let's just say we've got our base is 15. Seem to like 15 today. Let's say this length is 17. Now, at this point, I did that pause intentionally, by the way. A lot of students are going to go, oh, boom, yeah, 15 times 17, boom. But the thing is, this is not the height, okay? What we need is some more information in this case. So what I'm going to do is I'm going to say that there's the height there. And so that must be less than 17, so let's just say it's, I don't know, 14. All I did, 15 times by 14, which is, I'm going to do a quick math trick. That's the same as 30 times 7. Why? So I double this quantity and halve this quantity. That works. 30 times 7 is a whole lot easier. That is 210 units. There we go. So we'll say centimeters squared in this case. Say that's centimeters. Say that's centimeters. Another example. Okay, I'm going to change some of these. How did I choose those same numbers all over again? I'm going to change my numbers a bit because I want to show you an example of how they might not trick you, but it's a way you can be messed with in this case. Let's say our base is 1.2 meters and our height is 90 centimeters. So again, a lot of the time when we go too fast, we just take the numbers right in front of us and just start using them. But we're going to make mistakes if we go too fast in these things, especially if we go 90 times by 1.2, because that kind of suggests that this side is much longer than this side, but it's not. What we need to do then is make sure that we're using the same units. Now, there's two ways we can go on this. We can do 0.9 times by 1.2, but that's slightly more annoying because we're multiplying with decimals, which perfectly fine, you all know how to do it, but what I'm going to do instead is I'm going to say 90 multiplied by 120, and this first one is going to give me square meters, the second one is going to give me square centimeters. I prefer that. I'm going to do another multiplication trick. So 120 times 90 is exactly the same as 12 times 900, which I just find a little bit easier. So I'm going to do 900 multiply by 12, use my long multiplication method. So 2 times 900, 1,800. And then 10 times 900 is 9, whoops, did the wrong place, is 9,000. Add them together, 0, 0, 8, whoops, 10,800. So there we go. We have 10,800 square centimeters. Boom, done. So there it is. If you remember nothing else from this, you need to remember that the area of a trapezium is the top plus the bottom divided by 2, multiplied by the height. That's the average of these two sides. And the area of a parallelogram is just the base multiplied by the height, making sure that you don't use sides which are no use to you. And remember as well that the height is at 90 degrees to the base. Whoops, I'm using the eraser here. That the height is 90 degrees to the base. So there's a height there. Okay. You may also, for example, let's say the base, if I do another parallelogram actually. So let's just go for this one. Yep. Okay, so parallelogram. Luckily this ruler stays parallel as long as you want it to stay parallel. Whoops. Okay, and we'll tidy this up slightly. Ruler away. That is on object eraser. So, because this actually, yeah, this is another way these questions can sort of mess with your head a bit. So let's just say this is, I don't know, 12. I seem to love 12 today. Let's use a finer pen than that though. So 12 units here. We'll say this is 17 units. And we are given this. And we go, oh, what in the world do I do here? We'll just call that, I don't know, let's say that's 10. Well, the thing is, if we were able to rotate this around slightly, this would be the base and this would be the height because it is 90 degrees to this side. So then we go, all right, cool. 17 times 10 is just 170 in that case. Boom, there we are.